Hello, welcome. We're with RFMW here at IMS in Boston in 2026. My name is Tobias Hambach. I'm a supplier business manager with RFMW. And with me today I have Dave Raymond. He is a product line manager with Smiths Interconnect, a Molex company. Dave, welcome at our booth.
Yes.
And could you walk us through what you're displaying at RFMW this year?
Yes, so we make a series of RF components and fiber optic products. We do everything from board level, resistors, attenuators, thermopads, filters, ferrite product, and also some cable assemblies and some fiber optic transceivers. In the booth today, we partner with RFMW. They hold a lot of stock of our products so our customers can get it quickly. What we do at Smiths Interconnect is we like to be close to our customers, look at the upcoming trends and the design cycles, and we work with RFMW to generate new products and continually grow the product. So there's a big evolution in products year over year when we see new market trends.
As you can see, quite the range. Thanks for the quick introduction, Dave. Obviously, as you said, we stock a lot of this. We're helping customers with readily available stock. But on top of everything that you do daily, you also have something pretty exciting that's coming up. And I think you have a demo at your booth.
Yes, we have a demo at the booth of our newest series of KTVA products. And we'd like to show you that if we could.
Yeah, let's go check it out.
All right.
Made our way to the Smith booth, and Dave, why don't you show us and why don't you tell us what this demo is all about?
So at the booth we have several displays of demos of newer products that we're showing. This is our new K2 TVA. It goes higher in frequency. We've had in the past, we've had products when they get higher in frequency, they tend to compress and they don't get true shift at high frequency. What we've done here is developed a new design that gets us frequency high in the temperature range, and it's constant at high frequency. As you can see here, this part is on a heat sink at 125 degrees C. This is a 6 dB part, and at 125 degrees C, it's reading 4 dB. Now, when I spray this with cold air, you can watch the screen and watch the measurements change. Now it's coming down to the 6 dB because it's at room temperature. If I keep spraying and go colder, it's going to the cold side. So it shows you your true shift throughout the frequency range of this product. And this is particularly useful, we're seeing in space applications where they want to have a passive solution for temperature control instead of a complex active system. So thank you very much, Toby, for coming over and showing this product.
Thanks for explaining, Dave. Have a good rest of your show, and thank you everyone for watching.